Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. We've had a whole bunch of definitions about validity and invalidity, and in this video, I'd like to take you through actually using these definitions to show whether something is valid or invalid. The first thing, though, is to note that validity is a universal notion. It says something about all frames, all models, all worlds. You have to have truth in all of these possibilities. So in a sense, proving validity is tricky because if you check every world and every model on every frame individually and ask yourself, is it true in this one? Is it true in this one? You will be here for a very long time. Invalidity, on the other hand, is an existential notion. All you need to show that a formula is invalid is one world in one model on one frame that makes it false. We will use this to our advantage when trying to prove the validity of a particular formula. And we will do this by, you've got a formula. Do you want to know if it's valid or invalid? What's the easiest way to prove that it's invalid? Because all you need to do is find one witness. So if you can find a witness that makes it work, a world where it is false, you're done. If you can show that any attempt to come up with a world that makes it false runs into problem in the sense of you end up with a contradictory situation where you have some particular item that has to be both true and false at the same world at the same time, can't do that, goes against the definitions of models, then you know that you can't make it invalid, and therefore, what's the only option left? It has to be valid. So this is the method that we will be using, and let's see some particular examples. We will start with the formula. If P implies Q is necessary, then necessary P implies necessary Q. So the question that we want to ask is this valid? Yes, no. Well, we can start off the proof both ways. So if it isn't valid, then we should be able to come up with a counter model. And if we come up with a counter model successfully, we know that it is invalid. So let us start with that. Suppose it isn't. Then we know that there is a frame and a model on that frame and a world in that model that makes it false. So we'll just simplify this and say there is an M and a W such that this formula, necessary P implies Q implies necessary P implies necessary Q is false at that world. And in fact, I'm not even going to continue writing out all of this anymore. What I'm going to do is I'm just going to draw a little dot and I'm going to label it W. And I'm going to say we have a world where this is false. What would this world have to look like? Well, this formula is a conditional. There's only one way for a conditional to be false. That is when the antecedent is true and the consequent is false. Now, this third formula here is also a conditional and it's also false. What is the way for this to be false? If the antecedent is true and the consequent is false. Now, we've taken care of this one because we've broken it down into these two. We've taken care of this one because we've broken it down into these two. So what we are left is two necessity claims that are true and one that is false. Now, we saw I told you in the previous video, that every single necessity claim is true at a dead-end world. So if we don't build anything more into our model, this and this are the case. So both necessarily P implies Q and necessarily P. But right now, necessarily Q would also be true because this is a dead-end world. We need it to be false. This is the same thing as saying that it's possible that not Q. Now, in order for a possibility claim to be true, W has to be able to see a world, we'll call it W prime, where not Q is true or Q is false. Let me fix that very bad looking ambiguous T. There we go. But notice I didn't put tick marks next to these necessities, even at the point where I was like, okay, I'm fine, they're both true here. This is because anytime that you add a world to your model, you need to go back to the original world, look at your necessity claims, and make sure that they are still true. So necessarily, P implies Q is true at W if every world that W sees, here is W prime, makes P imply Q true. Same with necessary P. It has to be the case that P is true at every world W can see, including W prime. But now take a look at this. This says that P implies Q is true, P is true, but Q is false. This is a contradiction. So at no point did I have to make any decisions about what to do. Everything was necessitated by the truth conditions for the or falsity conditions for the various subformulas that we were considering. So what we know is that our assumption that there is a model and a world that makes it false led us straight into trouble. We've got a contradiction. So our assumption or supposition was bad, wrong, false. This formula cannot be falsified. Since it cannot be falsified, it is valid. Now, let's try something else, because it's useful to be able to see how it goes both when things go wrong, as it did here, and when things go right. So let me see if I can use, I thought there was a way that I could like magically create a new sheet on my whiteboard, but it's not working. Oh, well, we will just clear this one and begin again. Let us consider this formula. So necessarily, if necessarily P implies necessarily P, then P. And I need another bracket right there. So is this valid? Well, what do? You start off by suppose it isn't. Then, and I'm going to not write everything out. I'm just going to go straight to the diagram. Then this means that we have a model and a world. And at this world, we have that necessarily P implies necessarily P implies P is false. Now, remember what we saw in the previous one. As soon as you have a necessity claim that is false, this means that you need to be able to see a world where the bit without the box on the front is false. So that gets us necessarily, P implies necessarily P implies P needs to be false at this world. This is a conditional. The antecedents will therefore be true. Just got to get that P in there. And the consequent false. Now, this is just an atom. So if we were trying to create a frame and a model, well, we've got the frame here with W and W prime and W seeing W prime. And we would say that our valuation makes P false at W prime. So tick for the atomic level, can't do anything more there. We need to check this formula to ensure that it is in fact true. It's a necessity claim. W prime is a dead end. Every necessity claim is true at every dead end. Therefore, we can say that this is a model that makes this formula false. So what we have is no contradiction. This is a falsifying instance of this formula. And what we can say is that W consists of the set little w and W prime. R is the pair W, W prime. And V is, I'm just going to do this, is such that the value of P at W prime is false, because that's what we have here. And Everything else is arbitrary. So here's my frame plus valuation equals model. And here's our world that makes the formula false. So this one is invalid. We'll pause here because I don't want this to get too long and boring and complicated. In the next video, I'll go through some more examples. If you're feeling comfortable, just skip it. If you'd like to see more examples of things both that are valid and invalid, so you can kind of see what the various pitfalls and things to pay attention to are, then join me next time as we do more invalidity and validity. Until then, take care and see you later.